My talk today will have three main topics. The first is a very brief introduction to our organization, GN. The second is about how to manufacture individualized hearing aid. And the last topic will focus on how we utilize additive in our product development and our R&D activities inside GN. So, GN have a long history. The company was founded more than 150 years ago. Back in that time, the core business was to establish telegraph lines. Today, we are 6,500 employees globally, and we are headquartered in Ballerup, about 15 kilometers from here. And our business is focused around hearing and audio technology. Our business spans three different segments: hearing instruments and care services, audio equipment for enterprise, namely contact centers and offices, and finally, we have a series of retail products as well. If we take this to the product level, I brought illustrations here of three of my personal favorites. The first being one of our premium hearing aids called Resound 1. The second, a professional headset for call centers, etc., featuring no less than 10 microphones to give you crisp and clear noise cancellation and also high quality sound in noisy environments. And finally, we have the consumer grade products, the Jabra T85 earbud, which just brings a really high quality, comfortable fit to the user by building the design on thousands of ear scans to optimize the shape of the product. So now on to 3D printing. What we see in this slide is a selection of hearing aids where the shells get 3D printed to fit the individual user. The hearing aid industry was actually among the early adopters of 3D printing, and our industry have now been 3D printing shells for individualized products for around 20 years. As a collective effort by our industry, around 10 million of these devices are in use right now, and they are all 3D printed. I find that quite fascinating myself, and that's also why I choose to show you the workflow of how these products are created. The journey starts at a hearing care professional where a person with a hearing loss or hearing impairment is engaging in a dialogue with an audiologist, and through interaction and dialogue, they come to the conclusion that a customized hearing aid is the right solution for their needs. Then, by using a soft silicone material, the audiologist creates an impression of the ear channel of the patient or user, and that's what you see here to the right in the picture. This impression is then sent off to a GN production facility where a 3D scan is created of this silicone impression, and that results in a CAD file, which is what you see here to the right. By importing this CAD file into a dedicated software tool, a specialized technician iteratively designs, respectively, the shell of the hearing aid based on the CAD model, and also places all of the components and features inside the hearing aid. This is a manual step, and it's very important as the technician makes a lot of special considerations around comfort and also the audiological performance of the device. Then we move on to actual fabrication of the shell. When the design is done, shell fabrication takes place. This is happening through the well-known workflow of creating an additively manufactured part, where we first use a software tool named a slicer to cut the part in pieces, or the CAD model, in layers, and then we do the actual 3D printing on a DLP machine with a biocompatible resin. Post-printing, all components are placed inside the hearing aid, and mechanical assembly takes place. This task requires also specialized technicians, as we are dealing with micro-sized parts, and the designs also vary significantly from the individual hearing aids. As a final step, the hearing aids are both tested and inspected before they are finally approved and sent back to the hearing care professional, where the hearing care professional prepares the hearing aid for the individual user and provides them assistance and guidance in how to use the product. This was a short story through the workflow of creating a 3D printed hearing aid. This market segment, where we 3D print the individual devices, accounts for around 20% of the hearing aid market. For the remaining 80%, we still rely on more conventional fabrication or manufacturing technologies. And in that regard, additive manufacturing becomes a product development and research tool. And I also want to share a few notes on that and on how we work with these technologies within GN. But yeah, first a bit of a theory. Prototypes will always, in one way or the other, be different from a final product. That is their definition. That also means that the characteristics that a prototype have in common with the future product is actually what we can say use to predict something about the future product. Whereas the characteristics that are different on the counterpart might even create noise or disturb the results we get from our development activities. If we use a concrete example, we could say that if we 3D print a design using resin-based technologies, that part or design might perfectly well be used for industrial design purposes or to conduct user studies. But on the other hand, if we want to predict something or forecast something about how this part would perform in terms of mechanical abilities, strength, acoustic performance, or maybe how the material affects wireless signals, then it gets a little bit more tricky to work around. And yeah, let's proceed and see if we can find a few examples. Here we have a product called the Resound remote control. That's essentially, put very briefly, a small remote device that enables users to adjust the volume and switch programs on a hearing aid without touching the actual device. What you see here in the picture is 30 different design models that were fabricated in our lab back when we designed the product. Our industrial designers were perfectly obsessed about the form factor of this device and how they could make it intuitive to use, also for people maybe with dexterity problems and similar issues. And we really studied this rigorously with some of our users. And to fabricate 30 prototypes like the ones you see in this picture, that's definitely not rocket science. And it's probably also something that all of you have seen before. But I don't think, on the other hand, that it's something that we should neglect when we really want to create something that our users love to use every day. So plain simple use of 3D printing as a product development tool. But if we look, for instance, towards our hearing aids, things can also be a little bit more tricky. Hearing aids are delicate and integrated devices. It's often a challenge for us that the photopolymers used in the technologies that can deliver small micro parts like the ones we have in our products essentially deviate quite significantly from the ones we use in our injection molding and production activities. But fortunately, there's also ways around this. This slide here illustrates a range of testing activities that we have been doing. And it's all about indirect use of 3D printing. It's essentially tools and molds that are 3D printed but are intended for fabricating parts indirectly so that we can get the production grade material into the tool and get parts that very closely mimics what we want to obtain from our finalized products. And if we take this to the product level and try to make it a little bit concrete, what we see here is one of our newest products, or it is actually our newest product. It was announced less than 24 hours ago. It's called Jabra Enhance Plus, and it's a small hearing aid that is about 50% of the size of the earbuds we currently have in the market. Back when we were developing the Jabra Enhance, we really pushed the limits in terms of providing a compact and also comfortable device. And what you see here in between the battery part and the white frame part on the picture, or this exploded view, is a silicone tube. And sound travels through this tube. And in our efforts to save space in the early design stages of developing this product, we choose too thin a wall thickness for this part. And that essentially compromises the sound quality of the product. But when we were to update this part, we were questioning ourselves a little bit about how to go about it, because if we were a little bit under time pressure here. And if we choose to, say, 3D print new parts and iterations of this part, we would essentially end up with something that we wouldn't be able to verify, in the sense that the photopolymers from the 3D printer would deviate from the silicone rubber used in production. Also, another alternative would have been to fabricate a series of injection molding tools to realize this part. The project plan just didn't really allow for this timeline needed to do the tooling, not to speak of the cost itself. So what we did instead was to fabricate molds by 3D printing and fabricating parts in a silicone rubber that was very close to the one we intended to use in production. And when the product becomes available later this year, you can judge for yourself. I think we nailed it pretty well. I want to end this presentation with a note on sustainability. By 2025, GN is committed to use 50% sustainable materials in our new products, and to include product development requirements related to sustainability for every new product that we create. And I'm actually quite confident that through collaboration with our suppliers and partners will make it. I also find that additive manufacturing has a special role in this development. If we use the technologies in a smart way, they are not only relevant in reducing the footprint of our manufacturing industry, they are also very important in supporting prototyping activities to help us produce products that people truly love, also in the long term. And hereby, prototyping is not only a shorthand to innovation, it might also very well be a shortcut towards a more sustainable future. Thank you very much.
Thank you. Thank you, Lasse.